Hello, in this video you're going to see where integration by parts comes from. So first of all, let's go over the motivation for integration by parts. I'm going to presume we know how to integrate, for example, I'm going to presume we know how to integrate cos x. And I'm going to presume we know how to integrate something like x squared. But what if I asked you to integrate cos x times x squared? We don't know how to do that currently. And that is why integration by parts is useful. It tells us how to integrate the product of two functions. Now, when you would have encountered this in differentiation, we used the product rule. That was our way to circumvent this issue. And also understanding that differentiation and integration are opposites. It should come to no surprise that the way we derive integration by parts is through the product rule. Okay, so let's remind ourselves of what the product rule is. The product rule says if we have two functions of x, u and v, and we derive them, so let me just draw a line here, and we derive them, this is the same as deriving u and timesing it by v and adding the derivative of v times by u. This is the product rule. So what we're going to do is we're going to integrate both sides of this equation. So we're going to get the integral of uv differentiated, and this is going to equal the integral of u dash v plus v dash u. Okay, remember what we said about differentiation and integration being opposites. So this means that this is just going to be, the left-hand side of this is just going to be uv. Because I've differentiated uv and then I've integrated it. And note that we can split up integrals. So we can write this as the integral of u dash v plus the integral of v dash u. Okay. So now let's take away this integral v dash u from both sides. So we get u v minus the integral of v dash u equals the integral of u dash v. And now I'm just going to write this the other way around. So integral of u dash v equals uv minus the integral of v dash u. Now that, if you've seen integration by parts before, that should look familiar. And that is integration by parts. The idea is, if you have an integral of a product of two functions like this, using this fact, you can rearrange this, and hopefully this integral is something you know how to calculate.